the Dead Sea, one of the most iconic bodies of water on Earth, is disappearing. This unique salt lake, known for its extraordinary buoyancy and mineral-rich waters, has been a source of fascination for thousands of years. Its high salinity, nearly 10 times salter than the ocean, allows people to float effortlessly on its surface. The lake's mineral-rich mud has been prized for its therapeutic and cosmetic benefits, drawing visitors from around the world. But today, the Dead Sea is shrinking at a rate that has scientists, environmentalists, and locals deeply concerned. Its receding shoreline and the emergence of vast sinkholes paint a picture of a landscape under stress. To understand what is happening, we need to examine the complex network of natural and human-made factors that have led to this crisis. The Dead Sea is not a sea in the traditional sense. It's a salt lake located at the lowest point on Earth's surface, over 430 meters below sea level. This unique geographic feature makes the Dead Sea unlike any other body of water in the world. For millennia, it has been fed primarily by the Jordan River, along with smaller streams and underground springs. Together, these sources brought fresh water into the lake, balancing the high rates of evaporation caused by the region's intense heat and arid climate. However, over the past few decades, this delicate balance has been disrupted. The Dead Sea has been shrinking at an alarming rate, losing about a meter of water depth every year. Satellite images show dramatic changes to its size, with the lake now covering only about 2/3 of its original area. Entire sections of the shoreline that once sat underwater now stretch as barren, cracked ground. This shrinking is not just a visual change, it represents a critical disruption in the lake's ecosystem. The surface area reduction accelerates the concentration of salts and minerals, altering the chemistry of the water. While the Dead Sea is too salty to support most forms of life, these changes have implications for its unique microbial populations and the industries that rely on its minerals. The shrinking also exposes the surrounding land to new pressures. As the lake recedes, the once submerged areas become vulnerable to erosion and other geological changes, setting the stage for sinkholes and land instability. Local communities, businesses, and researchers have all sounded the alarm, pointing to the urgent need to address the factors contributing to the lake's decline. Understanding why this is happening requires us to look closely at the interplay of natural and human activity over time. While evaporation has always been a natural process here, the reduction in water inflows, coupled with industrial activity and other pressures, has pushed the Dead Sea to the brink. One major reason is the significant decline in the amount of water flowing into the Dead Sea. The Jordan River, once a robust source of freshwater, has seen its flow drastically reduced. Historically, the Jordan River carried approximately 1.3 billion cubic meters of water annually into the Dead Sea. Today, that number has dropped to less than 100 million cubic meters, an alarming reduction of over 90%. The reasons behind this decline are multifaceted. Much of the river's water is now diverted for agricultural irrigation and drinking water, primarily by the countries that share its basin, Israel, Jordan, and Syria. These nations have been grappling with increasing water demands due to growing populations, expanded agricultural activities, and urban development. Large-scale irrigation systems have transformed arid lands into fertile agricultural fields, but this has come at a significant cost to the region's natural water systems. In addition to irrigation, dam construction along the Jordan River and its tributaries has further restricted water flow. Over the past several decades, multiple dams and reservoirs have been built to store water for domestic use and agriculture. While these projects provide essential water security for millions, they disrupt the natural flow of the river, preventing it from reaching the Dead Sea. Compounding these issues is the role of untreated wastewater. In some cases, treated or untreated sewage and industrial discharge are released into the river, reducing water quality and making what little water does flow downstream unsuitable for sustaining the Dead Sea's ecosystem. Irrigation projects have been vital for supporting local populations and their agricultural needs. For instance, the Jordan Valley is home to extensive farming operations that produce fruits, vegetables, and other crops for both local consumption and export. However, these projects have also had unintended consequences. By redirecting so much of the Jordan River's flow, the water that once replenished the Dead Sea has been reduced to a trickle. Moreover, high evaporation rates in the region mean that a significant portion of the water diverted for irrigation is lost before it can even be utilized. Another contributing factor is mineral extraction. The Dead Sea is rich in valuable minerals like potassium and magnesium, used in fertilizers, cosmetics, and industrial processes. Both Israel and Jordan operate large-scale extraction industries along the lake's shores. These industries use evaporation pools to harvest minerals, which accelerates water loss. These evaporation pools expose large volumes of water to the sun, causing it to evaporate more rapidly than it would naturally. In fact, some estimates suggest that these operations account for up to 30% of the total annual water loss from the Dead Sea. While the industries provide economic benefits, their operations significantly impact the lake's water balance. As the water recedes, another troubling phenomenon has emerged: sinkholes. These sudden collapses in the ground are a direct result of the shrinking Dead Sea. Here's how it works. When the water level drops, fresh water from underground aquifers seeps into the now dry areas. This fresh water dissolves salt deposits beneath the surface, creating cavities. Over time, these cavities collapse, forming sinkholes. Sinkholes pose serious risks to local communities, infrastructure, and tourism. Some areas have become so unstable that they've been abandoned entirely. In certain places, sinkholes appear overnight, making the land unpredictable and dangerous. Tourism, which has long been a cornerstone of the local economy, is also feeling the effects. The shrinking shoreline has forced resorts to build longer walkways to reach the water, while some beaches have disappeared altogether. For many, the Dead Sea's unique natural features are becoming harder to access. To address these challenges, some initiatives have been proposed. One of the most ambitious is the Red Sea Dead Sea Water Conveyance Project. This plan aims to transfer water from the Red Sea to the Dead Sea, helping to stabilize its levels while generating hydroelectric power and desalinated drinking water. While this project offers hope, it has faced significant delays, high costs, and environmental concerns. Critics argue that introducing water from a different ecosystem could disrupt the Dead Sea's delicate balance, potentially creating new problems. The Dead Sea's plight is a reminder of how interconnected our natural and human systems are. The choices we make, whether for agriculture, industry, or development, have far-reaching consequences. While efforts are underway to mitigate the damage, reversing the decline will require coordinated action and long-term planning. The Dead Sea is a geological and cultural treasure, a place of immense beauty and historical significance. Its rapid decline is a stark warning of what can happen when water resources are stretched beyond their limits. Understanding the causes behind its shrinking is the first step toward finding sustainable solutions. If you found this video informative, consider subscribing to our channel. Together, we can explore the challenges facing our planet and the solutions that can make a difference.